In any triangle, guys, it's too much talking. In any triangle, now it's especially used for non-right triangles, but in any triangle, the ratio of any side to the sine of the angle opposite that side is true for any pair of angle and side. Okay? Again, it's given to you as all three groupings or pairings, but you're only going to use any given two. Right? And what I would recommend is use the form that provides the unknown in the numerator. Okay, so what I would do is I'd use this to find a missing side, and I'd use this form to find a missing angle. All right, so that's just a quick little recap of what the law of sines is. Now, the application on the law of sines, or using an inverse trig ratio to find an angle, was something that a lot of students continued to have trouble with, because if you get an equation, let's say you're setting up an equation from this bottom row, and let's say you wind up with the sine of a over 7 is equal to the sine of 23 over 5. Okay, a lot of you are having some difficulty in how do you enter this on your calculator and solve for it. Okay, so I'm going to review that here really quickly as well. Now, you can use the solve feature of your calculator for this. Okay, however, your calculator cannot solve for a variable that's embedded within a trig ratio. Your calculator doesn't take the inverse on its own. Okay, so what you're going to have to do, if this is the way that you're looking to solve a problem, is you're going to have to basically let x replace the whole trig ratio. And so what we're going to do is we're going to plug in an x for the sine of a, and we're going to solve for that x. And now notice we're not solving for sine of x. We're taking x and we're putting it in for the whole trig ratio. So when we use our solve feature here, x over 7 is equal to, again, make sure you're in the correct make sure you're in the correct mode. And they're in degree mode here. So the sine of 23 over 5, solve for x. And now I'm going to put this in decimal form. And the answer that you get when you solve for x here, so in this particular case I got 0.547. And notice, that's not my angle measure, that's the sine ratio of my angle measure. And so in order for me to find the actual angle, we use the inverse trig ratio. So if you have the equation sine of a is equal to this, all that's telling you is in your triangle, the sine ratio of angle A is the ratio of 0.547. So if you want to find what angle A is equal to, you take the inverse trig ratio of, or the inverse trig ratio of that number. So what we would do with this is we would take the inverse sine of this quantity and solve. Now, you can do this a couple different ways. You could go highlight it like I just did. You could highlight it, pull it down. You can delete the x equals. You could even just leave the x equals. It'll still give you an answer. It tells you the inverse sine of that angle is 33.2 degrees about. Okay, so this is what the measure of angle A would be. Okay. So make sure that you're aware of how to use your calculator to find that. Okay. Questions about that? Hopefully you took notes and then followed through the progression of it if you still did have some issues calculating. All right, so let's actually go through one versus two solutions on the SSA pattern. And so remember, law of sines applies for three patterns of information. Okay, the two patterns that contain two angles, so ASA and AAS, and those are the ones that we've gone through in a little more details. But then the other one, the last pattern is SSA. Now, because SSA isn't a congruence pattern, so it is not a congruence pattern, it's possible that there's cases where there's one solution, and there's cases where there's two solutions. Okay? So just really quickly, the distinction between the two has to do with the measures of the pieces of information. Okay? So if you're given an angle, so let's say we're given this angle of 23 degrees, and we're given two sides. So let's say a side of 15 and a side of 10. Depending on how those sides are related to each other will determine whether you have one or two solutions. Okay? The comparison is if the side opposite the given angle is smaller. So think about it. If this is smaller than 15, is it possible for us to kind of swing this piece back over here and form a second triangle with the same set of angle 23, side of 15, and opposite side of 10? Yeah, now think about, because you're forming this isosceles triangle in here. When you look at this green triangle, it's an obtuse angle, or it's an obtuse angled triangle here. So is it possible, or would it be consistent for this side of 15 to be opposite the obtuse angle when the side of 10 is opposite an acute angle? Yeah, because the larger the side, the longer side has to be opposite the larger angle, and that's consistent here. So this is the case where there's two possible solutions. And now, what about in this case here? So on this one, when we try to swing this back, let's just assume we draw it so it's not drawn to scale. But if we look at this, can we have an angle of 23, 10, and where this is 15? Well, look in this triangle here, this green triangle. Would it be possible for this green triangle to exist if the side opposite its obtuse angle is 10 and the side opposite its acute angle is 15? No, because the longer side has to be opposite the greater angle, right? So it can't work on that. And so again, that's sort of just the visual demonstration of it. And so this is the case where you just have one solution. Okay. All right, so again, often the problems that you're going to have, I'll specifically tell you, name both solutions, and then I'll give you information about the points in order to determine that. Okay. So let's take these two examples here, and let's see what the measures are if we work through them on the SSA pattern, depending on whether we have 10 or 15 as the side opposite the given angle. And so let's start with the one with the two solutions, since we haven't done that one yet. All right, so if you have the following triangle, so that would be our angle of 23 degrees, our side of 15, and the opposite side of 10. This is consistent with our two different angles. I'm sorry, the two different solutions. Okay, and so let's find what these solutions are. So we have B, C, and side B. And then we have our second solution, we'll call it B2, C2, and side B2. All right, so when we work to solve this, what's the very first piece of information we can find up here in the top using law of sine? We have a pattern of SSA. We do need to remember in each of these, or in the law of sines, we need to find our set ratio, the ratio that we know. So the ratio of our side to the angle is 10 and then sine of 23. So what's the measure that we can find given the side of 15? Yeah, we can find the side or the angle opposite that, right? So when we set up our sine ratio, once again, we can use either of these forms. Since we're finding a missing angle, I always put the unknown piece on top. So my unknown is an angle, so I'm going to say that the sine of C over the side opposite that, 15, is equal to my known ratio. My known ratio is the sine of 23 degrees over the side 10. All right, now I'm going to go ahead and use my calculator to solve this. But remember, this is that case where your calculator cannot solve for a variable embedded within a trig ratio. So what we want to do is we want to let x, in this case, equal the whole ratio sine of c. So I'm going to put an x here, and I'm going to solve for x. Okay, so that's my substitution. But this is what I'm solving for. So when I enter this, I'm going to use my F2 algebra tab, solve, enter my equation, x over the sine of 23, I'm going to put a decimal in there so it gives me my answer in decimal form, is equal to, oops, set up wrong. So we're going to put it in the equation, x over 15 is equal to our sine of 23. I'll put my decimal in there, divided by 10, and I want to solve for x. So what this is going to give me is the sine ratio for my angle C. So when I hit enter, I expect it to be a value between -1 and 1, right? Any sine or cosine ratios have to fall between that. So I get x to equal 0.586 approximately. And that has to be what my sine of C is. So that means my C value can be found by taking the inverse sine of that same ratio. Okay, so if I just take the inverse sine of that ratio, and so in this particular case, I'm going to go ahead and get rid of my x equals. Okay, and I hit enter, and I get my angle to be 35.88. And that's in degrees. So I found my angle here, 35.88. So now what can I do to find angle B? I have two of my three angles, so all I need to do is subtract those two from 180. So if I take 180 and I subtract 23 and then I subtract the angle I just found, I get my measure to be 121.12 approximately. All right, now my final step is to find side B. Well, side B, we can solve for it using, again, the same thing that we just did, the law of sines, only this time our unknown is going to be this side B. So when I set up my ratio, which I'll do in blue again, I'm going to set it up as B over the sine of the angle opposite it, which I just found to be 121.12. And that's equal to, and it's going to equal the same ratio I started with, except now I'm going to flip it because my sides are on top and my angle's on the bottom. So 10 over sine of 23. And I'm going to use the solve feature on my calculator to solve for this. And now my variable is not embedded in a, it's not going to be embedded in a trig ratio. So when I solve, I'm just going to exchange my x for the b, and it will solve this exactly for me. I don't have to do a substitution here other than just what I'm plugging in. So I'm going to set it up as x divided by, in this case, the sine of, I'm going to highlight the actual angle measure, 121.12. Set that equal to the ratio that we were given, 10 over the sine of 23. Close that off and solve for x. Again, this is going to give me my actual value for the side B. Okay, so that gives me 21.9, and if I round up 1, is my B value. Now, is that consistent with what you would expect? Okay, with the measures that we have right here, is the smallest side opposite the smallest angle? Is the longest side opposite the largest angle? Yeah, so at least it's consistent. You want to make sure that you have some consistency there. All right, any questions on finding this first triangle? All right, so here's the steps for finding the second one. And again, it's very systematic. Okay? However, if you don't have in your notes a detailed description of what you're doing, you might not be able to find it. Okay, but here's what you would do. Now imagine what this second triangle looks like. Remember, the second triangle looks like we take this point C and we rotate it back inside, and we form this smaller obtuse triangle inside, right? We still have the measures of 23 degrees, a side of 15, and an opposite side of 10. And now notice the triangle that's created here. This is our new C value, C2. Our B value, our B point stays the same, but the angle measure changes. But if you look at where C2 intersects here, we're creating this isosceles triangle. So in order for us to find C2 right here, what's the process that's necessary? C2, we don't have to do any any detailed calculation. It's a very basic calculation. If this angle right here, this base angle of an isosceles triangle is 35.88, what's this angle right here going to be? Yeah, it's the same angle, right? The base angles of an isosceles triangle are the same. So what is this new angle C2 going to be? You can find it by taking 180 minus the original angle, 35.88. So if we took 180 minus, and we scroll up to 35.88, we get our measure to be 144.12. So that's our angle measure. So what would we then have to do to find the last remaining angle B2? Take this measure along with 23 and subtract it from 180, right? So if we took 180 minus the given angle A, which stays the same, 23, minus the angle that we just found, 144, we get our measure for the new B angle, 12.88. So this angle right here is 12.88 degrees. And so the last step that we have is this side right here, B2. And so our B2 calculation, I'll do it in blue again, is a law of sines. Savannah, question? So we took the sum of the angles of the triangle, right? We were given 23. We just found 144. So if we combine those and subtract them from 180, you get your 12.88. Okay, and so the last step here, we set up our law of sines once more for B2. B2 is our unknown, so B2 over the sine of the angle opposite it. Now that new angle became 12.88. We just solved for that. Set it equal to the same ratio that we just did prior to this, 10 over the sine of 23. Use the solve feature on our calculator. Again, I'm going to change B2 to an X just to make it easier to type it in. But I use the solve feature. X over the sine of this angle that we just found. Set that equal to 10 divided by sine of 23. Solve for X. And again, it's going to directly give me the measure of that length B2. Now, what are we going to expect from this? Is B2 going to be the smallest, largest, or middle size side? Should be the smallest, right? It's opposite the smallest angle. So this should be less than 10. So when we hit enter, we see that it's 5.7. Again, consistent with what we were expecting. 1 if we round it to 2 decimals. All right, so does everybody see really the only, this starred step is the one step that allows you to find that second triangle, okay? And it's based on the fact that you create an isosceles triangle as a reference point to find that measure.